Hello, for today's lesson we are talking about the distance formula. So let's go through a little reminder about the coordinate plane just to make sure we're all on the same page. So when we look at the coordinate plane, we can divide it into 4 quadrants and we go around counterclockwise, where quadrant 1 is where I have all positive coordinates. Quadrant 2, the x's are negative, the y's are positive. Quadrant 3, negative, negative, and quadrant 4, I have positive x's and negative y's. And remember, our coordinates are x comma y, so x is how far left or right, and y is how far up or down. Okay? And then the point 0, 0 is called the origin. A lot of times we'll call it O. All right, so here's our distance formula. So the distance between 2 points, A, x1, y1, and B, x2, y2, is d equals the square root of the quantity x2 minus x1 squared plus the quantity y2 minus y1 squared. Now, a little note, these 1s and 2s down here, these are not a value. They're just kind of like telling you the difference between the x coordinates. So for instance, this x coordinate is the x coordinate of my first point A. This x coordinate is the x coordinate of my second point B. So it's just calling A point 1 and B point 2. Okay, so let's do an example. Example, find the distance between T at 5, 2 and R at negative 4, negative 1. So in order to do this, I'm going to call my first point x1, y1, and my second point x2, y2. So then I have x1 equals 5, well, here, let me write it like this. So x1 equals 5, y1 equals 2, x2 equals negative 4, and y2 equals negative 1. Okay, so now if I plug it into my distance formula, I'm going to have x2 minus x1. So x2 is negative 4 minus 5 all squared plus y2, negative 1, minus y1, 2 all squared. And then remember your good old friend PEMDAS. I'm going to go through and simplify inside parentheses first. So then I get a negative 9 squared plus a negative 3 squared. Now remember, negative 9 squared is going to equal negative 9 times negative 9, which gives me a positive 81. If the negative was not in parentheses, for instance, like this, then that's going to be negative times 9, which would be a negative 81. So you're always squaring what the 2 or the exponent is closest to, and when it's closest to the parentheses, make sure you square everything inside of those parentheses, okay? So now I get negative 9 times negative 9 is positive 81. Negative 3 times negative 3 is positive 9. So now I have the square root of 90. And our goal is to put that in simplest radical form. So what I'm going to do is, let's see if I have any perfect square that is a factor of that. 9 is. Okay, so then I'm going to get 90 is 9 times 10. So then I get that I have the square root of 9 times the square root of 10. And the square root of 9 is 3. So my final answer here would be 3 root 10. And when we talk about distance, a lot of times we have units related, and you don't say you would live 3 root 10 miles away from school. So most of the time when we're talking about distance, we do in fact give a decimal approximation. So I'm going to go ahead and plug this into my calculator, and I'm going to round to the nearest decimal. So I get about 9.5 units, okay, because it's distance. All right, let's try another example. Our next one says, suppose you let negative 4, negative 1 be the first point, and 5, 2 be the second point. Do you get the same result, and why? All right, well, let's look at this. So if I look at this, my x1 and x2 are put together in this expression here. x2 minus x1 quantity squared. And then my y2 and y1 are put together in this expression here. -1 minus 2 quantity squared. So if I switched those, I would get -4. So, oops. If I switch those, I would get a 5 minus -4 squared plus a 2 minus -1 squared, which then would be a 9 squared and a 3 squared. Well, 9 squared and 3 squared are the same as -9 squared and -3 squared, so I would still end up with this same step right here where I have square root of 81 plus 9. Square root of 81 plus 9. So the answer is yes, I get the same result. So yes, same result. And if you think about the idea of distance, distance doesn't change based on the direction. So your distance from your house to school is the same as the distance from school to your house. So distance doesn't measure direction. Okay, so yes, same result. Distance does not measure direction. Okay, and in the process of squaring the difference, that's mathematically, that's what's happening. When I square the difference between two things, I'm going to end up with the same number. And the square of the difference of two numbers is the same no matter the order of the numbers. All right, let's try the third example. So the third example says segment AB has endpoints 1, -3, and -4, 4. Find AB to the nearest tenth. Okay, so reminder, just AB without the line over it is talking about the length of segment AB, and nearest tenth is to the first decimal place. So go ahead, pause the video, try this one on your own, and then hit play and see if you get the same answer as me. All right, here we go. Let's do this problem. So my distance, let's see, we need to figure out which points x1 and x2. It doesn't matter. So x1, y1, let's call that the first point here. And x2, y2, let's call that the second point here. So then my distance is going to be -4 minus 1 quantity squared plus 4 minus -3 quantity squared. So difference in the x's plus difference in the y's squared. All right, so then I get the square root of -5, all getting squared, plus 7 squared. So now I have the square root of 25 plus 49. So let's see here. What is the square root of 25 plus 49? This is where I need my handy dandy calculator, more handy than I have it. So 25 plus 49 is 74. And this problem does not ask for simplest radical form, it just asks the nearest tenth. So I can go ahead and find the square root of 74 on my calculator right away without doing simplest radical form. And I get about 8.6 units. All right, let's do the next example. Next example, we have a picture here. It says, each morning Juanita takes the Blue Line subway from Oak Station to Jackson Station. As the map below, shows, Oak Station is 1 mile west and 2 miles south. So 1 mile west and 2 miles south of the City Plaza. Jackson Station is 2 miles east and 4 miles north of City Plaza. Find the distance Juanita travels between Oak Station and Jackson Station. Okay, well, let's look at the map. So we're looking for Oak Station and Jackson Station. We want the distance between those two. Okay, so Oak Station is right here. So Oak Station is at -1, -2, and Jackson Station is at 2, 4. And the city center or the city plaza is in between them, right? So they are connected with a line, so she's not going out of the way. So I can just find the distance between those 2 points. So I'm going to call this first point here x1, y1, and the second point x2, y2, and go ahead and plug it in to my formula. So x2 is 2 minus x1 is -1 squared plus y2 minus y1 squared. So now I get -2, so 2 negatives become positive, so I get 3 squared plus 6 squared. So I get square root of 9 plus 36, or the square root of 45. And so when I do this one, we are talking, let's see here, we're talking miles. You don't need to talk about miles in simplest radical form. So we can just plug this into our calculator. And we're going to get is approximately 6.7 miles. All right. Next, let's talk about the relationship between the distance formula and the Pythagorean theorem. So we've been talking about, we did the Pythagorean theorem last class, and this class we're doing the distance formula. And so if I have a triangle, or if I have 2 points, let's say we have 2 points. So here's my point, x1, y1. And here's another point, x2, y2. Okay? So the distance formula says in order to find the distance between them, the first thing I need to do is I need to find the difference in the x's. Okay? So if I look here, the difference in the x's is going to be from here to here, right? So if this is, here, let's put this on a coordinate plane, might be easier. Okay, so here is x1, and here is x2. So this distance here, from here to here, would be x2 minus x1, okay, which we're going to call A. Then I can do the same thing with the y's. So my distance formula says, take the y coordinates. So here is y2, and here is y1, and find the distance between them. So this distance here is going to be y2 minus y1, which we're going to call B. So then my Pythagorean theorem, so good old Pythagoras, says a squared plus b squared equals c squared. Okay, so then that would be c over here. And my distance formula says if I take a squared, so a, remember, is the same thing as x2 minus x1, so x2 minus x1, and I square it, then I add the y's, so remember my y's, y2 minus y1 is b, so b squared is the same as y2 minus y1 quantity squared. Well, that's going to be c squared, right? Because c is the distance between those 2 points. Or it's going to be c when I take the square root of it. Sorry, that's the distance formula. But if I square both sides, now I get c squared equals x2 minus x1 quantity squared plus y2 minus y1 quantity squared, which is the same thing, right? Because b is the difference in y's, a is the difference in x's, and c is going to be the distance between the two. Okay? So that's why we have a square root in the distance formula, because it isolates just the value of c, the hypotenuse. And in the Pythagorean theorem, we can use it for all 3 parts, a, b, and c. Okay, so hopefully that makes a little bit of sense. Put that in your own words, Or if you want to draw your own picture and take a screenshot or something and put that in your notes, that's fine too. However you want to describe this relationship of these two to yourself, that's what's going to go in your notes. All right,